All right, hello and welcome everyone to our next lesson. This would be like lesson 7 of trigonometry. Again, we're right near the end of trig, to be honest. This is kind of our last new skill we need to cover for this part. It is called angles of elevation and depression. And here is a picture found from the internet showing, a man who is standing. If he looks straight ahead, he's looking horizontal. He's not looking with any angle of elevation or depression. You're looking straight ahead. The moment he looks up to see the plane, he's looking with an angle of elevation, and that is the angle above the horizontal. If he needs to look down at something, right, the moment you look down below the horizontal, you're looking with an angle of depression. So, just like always, you will need your equipment, maths book, pens, calculator. Pause the video if you haven't got them yet. Go grab your equipment, come back, we'll play the video. And again, just like always, we'll look at some examples. I'll give you some questions to practice. And if you guys have any questions or any follow-up, if you need any explanations or anything like that, you leave the questions afterwards and I'll definitely get back to you. All right, on to the lesson. This is our title and notes for this lesson. So pretty simple. Notes are kept quite short as per always. So pause the video, get your new heading and notes into your book as you're writing this in. If you're a slow writer, pause it. If you're quick, you can probably just keep up with me. Anyway, angles of elevation, that is the angles above the horizontal. Angles of depression are the angles below the horizontal, just as was shown in the image of the man. All right, so there are notes. Let's get into our examples. Now, what makes these very different from all the other questions we've had so far in trigonometry is there's no triangle, right? Trigonometry is the question with triangles. All of a sudden, you get to this part of trigonometry, you get right to the end, and there's not even a triangle in sight. Well, we're going to have to read the words and create our own triangle. A triangle still exists. It's just in the written form at the moment. Okay, so a plane takes off with an angle of elevation of 8 degrees. So presumably, the plane, I'm going to go about creating a diagram here. The plane is on, it doesn't say it here, but we're going to assume it's on like flat ground because that's typically how they make their runways. So we've got this plane and it's taking off. The angle of elevation is 8 degrees, meaning as the plane is taking off, the angle of elevation, that means above the horizontal is 8 degrees. So it's taking off, it's going up. That angle is 8 degrees above the horizontal. So the plane is taking off. Here it is. Plane is now here. Wings and stuff. And like people are happy, I'm guessing. All right, how high is the plane after flying 800 meters through the air? All right, so we've created, bam, our triangle. We had our ground. We took off at 8 degrees. Here is our triangle. What are we trying to find? We're trying to find how high the plane is. So they're asking us to find this distance here. And what have we been given after flying 800 meters through the air? So which distance here is 800 meters? 800 meters through the air is certainly indicating that's 800 meters there. So at this point, we have created a triangle. You can pretty much ignore all talk of planes, ground, elevation. This is now just a normal trigonometry question. Here, I'll brush it up. There it is, just looking like any other question we've always seen. Right, so in this case, we're actually trying to find a side length. This is kind of cool. We learned how to do this last week. We haven't had a chance to practice this skill this week, so I'm actually really happy for this question. So we're just trying to find how high this plane is. So we're trying to find x. Maybe I should have kept the picture of the plane in there. Bang, there it is. How high is the plane? Okay, so step 1, label the sides, hypotenuse, opposite. Okay, a lot of you probably already knew you didn't need to see SOHCAHTOA written there. O and H is sine, and that's okay. If you want to make sure of things, keep writing SOHCAHTOA in, right? Remember, you're brand new to trigonometry. You've only really been seeing this for a couple weeks now. Okay, sine is equal to opposite over hypotenuse. So you write out your trig ratio. Next step is to solve the equation. And in this case, we learnt the rule, when x is on top, you times. When x is on the bottom, you divide. X is on top, so it'll be 800 times sine 8. And so ultimately, all you need to do is just type this into your calculator. So type it in. Hang on just one sec. Sorry, Andy. Just need it a bit lower, okay? Okay, so you type this into your calculator and you press equals, and you end up with, I believe, if done correctly, we weren't told what to round to, by the way, so I'm just rounding to like the nearest meter. 111 meters above the ground. All right, so you end up with 111 meters as your answer for that one. If you really wanted to be fancy, you could then write it out nice and neat. Like, for example, therefore, the plane is 111 meters above the ground. It's nice. I kind of like it. It certainly signals back to the idea of this was a written question. Let's give a written answer. But realistically, from a practical standpoint, when the maths teacher sees 111 meters, and maybe we should probably indicate that we've rounded to the nearest meter, you're going to be given, the marks of the question, let's be honest. Next example, by the way, make sure you have this copied in. I apologize for the writing. If it makes you feel any better, I also had to write it down. So pause the video, get this example copied into your books, nice and neat if you need to, so you've got it there. We'll move on. We've only got 3 examples in total, so this lesson won't be too long. All right, example 2. Again, we've got ourselves a couple sentences here. We're not used to seeing this in maths, but fortunately, it's only a small part of it. All right, so the next scenario is a person on a 45-meter high cliff sees a boat at an angle of depression of 32 degrees. How far is the boat from the base of the cliff? Okay, so we can see the cliff here. It's in gray. And there's a man standing at the top. The cliff's 45 meters tall in total. For the man to see the cliff, he needs to look with an angle of depression. Here it is here. Angle of depression of 32 degrees. So that means if the man is looking horizontally, there's the horizontal, right? But for him to see the boat, he needs to be at an angle of depression of 32 degrees. That means you need to drop down 32 degrees from the horizontal to then see the boat. So that there is 32 degrees. So that's what that part means. And we're trying to find how far the boat is from the cliff. So again, we've got this scenario where we're trying to create a triangle, right? We had a part of a diagram which was of water, a boat, a cliff, and a man, right? That's not normal trigonometry. Trigonometry is triangles. Let's create a triangle. So we have side, that's 45 meters. We have some other side, which we don't know. And we've got this side here. Well, we know something about that angle. That's 32 degrees. Now, I know myself in year 9, the way I would have done this is I would have said, hey, if that's 32 degrees there, I would have known that this entire section here is 90 degrees. So what I would have done is gone 90 minus 32, and I would have said that angle there is 58 degrees. That's personally how I would have done this question and did do these questions back when I was in year 9. I always found that angle there because I knew they added up to 90. And then I would get the angle. Why do I even want this angle, right? Because we want an angle inside the triangle, right? This is trigonometry. You know, when you see the normal triangles, you have, if you're trying to find a side length, you need an included angle. You got to find an angle inside the triangle. So I would find that as 58. With that being said, I know some people really like using that Year 7 alternate angles skill. I'm not sure if you remember totally, but when you're looking at parallel lines and you learnt like the Z shape, do you remember that where you had like the Z shape, they're alternate angles and they're equal to each other? Well, that random Year 7 skill, Angie, just a bit more gentle, please, gentle voice. That random skill that you learnt in Year 7, which you thought, what was the point of this? You'll never need that again. Well, you can actually use that here if you wanted. All the way up in Year 9, you could actually say, if that's 32 degrees, you could use the Z shape. And then from that, say, hey, alternate angles, that angle there will also be 32 degrees, which is true. So it's up to you how you choose to do it, whether you're going to, use the alternate angles trick from Year 7 or have those two top angles need to add up to 90. It's up to you which angle you choose to do. You will still end up with the same answer. It doesn't matter which angle you go for. I will use the alternate angles because I know from the past, most students seem to prefer using that. Even if they don't remember Year 7, they just, I can remember that trick now, so that will be easy enough. If 32 degrees is the angle up there, Z shape, that's 32 degrees there. And we have our triangle. All we're trying to do is find how far the boat is from the base of the cliff. So they're asking us to find that length there. If I was to, redraw the triangle a little bit neater without all the extra fluff, that's 45 meters, that's X, and this angle inside is 32 degrees. And we're just going to solve this just like normal. Label your sides. We have opposite and adjacent. So we have ourselves another tan question. Tan 32 is equal to opposite over adjacent. And in this case, the X is on the bottom. Right, remembering back to last week, when you're finding a side length, if the X is on the top, you times. If it's on the bottom, you divide. So this will be 45 divided by tan 32. Type that into your calculator, press equals. That's all you do. If I've done it correctly, which big question marks over, I believe when you type that in your calculator, to the nearest meter anyway, you get 72 meters. So that boat is 72 meters away from the cliff. All right, final example. So far, our elevation depression, we've found like side lengths. Right, we were given the angle of elevation for the first one and asked to find like a length or a distance. The second one, we're given the angle of depression and then again asked to find like a distance. But it can work the other way. Sometimes you're asked to find the angle. And so what I've done is for this final example is Angie, gentle voice, please. Thanks, buddy. So for this final example, I've just reworked the last example around, so we're now finding the angle of depression. And obviously I've changed the numbers, so they're going to be different angles. So we have a person on a 60 meter high cliff, right? You got to make it better, got to make it bigger. There's a person on a 60 meter high cliff and sees a boat 450 meters away from the cliff base. What is the angle of depression? I was really proud of the limited number of words I needed here. Okay, so what is the angle of depression? So the idea is if he's up there and he's got this massive like laser cannon, he wants to blow this ship apart, or maybe he's more of the scenic type person, he has binoculars and he wants to look at the boat, right? What is the angle he needs to drop down from the horizontal to aim, whether it's binoculars or laser cannon? So again, think with your angle of depression, you're talking about the horizontal. That's him if he was looking straight ahead, or if he had his big laser cannon pointed straight. It would be aiming off in this direction, right? Obviously, he's not going to see the boat at all or be aiming at it. He needs to use an angle of depression. What we're trying to find is, what angle does he need to aim downwards? What is this angle here? That's the angle we're trying to find. And so, if we turn this thing into a triangle, because we want to make this question look just like a normal question. You spend 2 weeks working with triangles, all of a sudden you get a question, there's no triangle? Well, it's still trigonometry, you still want a triangle. You draw a triangle, put all the information in, and the question just becomes a normal question. So again, I'm going to use that alternate angles, trick from year 7. If that's theta up there, think of the Z shape. This will also be theta down here. They're the same size, those 2 angles. All right, so we're trying to find this angle. This is the angle of depression. So again, if you're finding the diagram a bit hard to follow, just redraw it if you need to. That's 60. This is 450. And this is the angle we're trying to find. Again, I'm going to say we've got opposite and adjacent. Yet again, I've got a tan question. I'm sort of struggling to avoid those at the moment. Not that I want to avoid them. Tan is a fun trig identity. And you know what? Probably gets used more than sine and cos in the real world anyway. So tan theta is equal to the opposite over the adjacent. Right? Where am I getting that from? Right? SOHCAHTOA. We had O and A, so we're using this one. That's how I got at the trig ratio. That was step 2. Step 3, solve the trig equation. You've got to move tan to the other side where it becomes a tan to the minus 1. And then, you type it into your calculator. They haven't told us to round to the nearest minute or degree, so you can choose. And of course, I'm going to round to the nearest degree. So you type that in your calculator. You press equals. You get an answer. I think it's that. I may be wrong. I'm sure you'll let me know if I am. And and that's how you get your angle. And then again, if you wanted to, you could write it out nice. The angle of depression, from the man to the boat is 8 degrees. Ultimately, if the teacher sees 8 degrees there, they know you've done it correct. And you've done fantastic. Now, this particular lesson, I don't have any questions in the video. That'll be separate. So there'll be a link to either the textbook, if you prefer to do that, or an Education Perfect lesson, if you would prefer to do your practice through that. It's totally up to you. All that's important is that you practice. So I'll leave it there. You know what to do if you have any questions. You can leave them either here on YouTube or through Canvas, and I'll get back to you. Best of luck, and I'll see you for the next one.